Hello everyone, welcome to new class. Today's class is the continuation of diagonalization of matrix. So in the previous class we have discussed about the diagonalization of a matrix of order 2 by 2. So next is the diagonalization of matrix of order 3 by 3. So let us go through the problems. Diagonalize the matrix A equal to 1 6 1 1 2 0 0 0 3. So our first step is find the eigenvalues and eigenvectors. So for that characteristic equation is determinant of A minus lambda I equal to 0. That is 1 minus lambda, then 6, 1, 1, 2 minus lambda 0, 0, 0, 3 minus lambda equal to 0. Now finding the determinant 1 minus lambda into 2 minus lambda into 3 minus lambda minus 0, then minus 6 into 1 into 3 minus lambda, that is 3 minus lambda minus 1 into 0 equal to 0. Now expanding this one, 1 minus lambda into, here we will get 6 minus 6 plus lambda square, then minus 5 lambda minus 18 plus 6 lambda equal to 0. Again expanding this one, 6 plus lambda square minus 5 lambda minus 6 lambda minus lambda cube, then plus 5 lambda square minus 18 plus 6 lambda equal to 0. Then here minus lambda cube, lambda square, 5 lambda square plus 6 lambda square, 5 lambda, 6 lambda, 11 minus 11 here, then minus 5 lambda, 6 minus 18, that is minus 12 equal to 0. That is multiplying by negative 1, then lambda cube minus 6 lambda square plus 5 lambda plus 12 equal to 0. So while finding the factors, that is using the calculator, we can find the factors. So we will get lambda equal to minus 1, then 3 and 4. So this is the eigen values. Now we have to find the eigen vectors. So lambda equal to minus 1, 3, 4 are the eigen values. So using the calculator we can find the factors very easily. That is, in the calculator we have to select the equation mode. So 1, then we have to select degree 3 because here lambda raised to 3. So degree 3 we have to select. Then A means lambda cube coefficient, that is 1. Then B, that is minus 6. Then C is 5. Then D is 12. So x1 is equal to 4. Then next is x2 is equal to minus 1. Then x3 is equal to 3. So these are the factors of the given characteristic equation. So we will get the eigenvalues as lambda equal to minus 1, 3 and 4. So when lambda equal to negative 1, using the equation A minus lambda I into x equal to 0, let us write, that is put the value lambda equal to negative 1 in this equation. So 1 minus minus 1, that is 2, then 6, 1, 1, 3, 0, 0, 0, 4 into x1, x2, x3 equal to 0. Now let us find the rank of this matrix. So for that let us interchange these two rows, that is R1 interchanged with R2. 1, 3, 0, 2, 6, 1, 0, 0, 4 into x1, x2, x3 equal to 0. Now let us make this element 0, that is R2 implies R2 minus 2 times R1, that is 1, 3, 0, 0, 0, 1, 0, 0, 4 into x1, x2, x3 equal to 0. Now let us make this element 0. That is R3 implies R3 minus 4 times R1. 1, 3, 0, 0, 0, 1, 0, 0, 0 into x1, x2, x3 equal to 0. Now, what is the rank of this matrix? So, rank is equal to 2. That is number of non-zero rows. But the number of unknowns are 3. So, we have to assume value for n minus r variables. That is 1 variable. So, from this equation, we can write x1 plus 3x2 equal to 0 and x3 equal to 0. So, let us assume x2 equal to k. Then x1 will be equal to minus 3k. So what is the eigenvector? So eigenvector x1 is equal to minus 3k, then k and 0. If k is equal to 1, then we have minus 3, 1 and 0. So this is eigenvector corresponding to lambda equal to negative 1. Now let us find the eigenvector for lambda equal to 3. So when lambda equal to 3, this equation becomes 1 minus 3, that is minus 2, 6, 1, 1, 2 minus 3 is minus 1, 0, 0, 0, 3 minus 3 is 0 into x1, x2, x3 equal to 0. So here what is the rank of this matrix? So rank is equal to 2 here, but the number of unknowns are 3. So we have to assume value for n minus r variables, that is 1 variable. So from this equation we can write minus 2x1 plus 6x2 plus x3 equal to 0. Then x1 minus x2 plus 0 x3 equal to 0. So here to solve for x1, x2 and x3, either we can go for the Gauss elimination method. That is, let us assume a value for n minus 1 variables. Then we can solve for x1, x2 and x3, or we can solve by cross multiplication. That is, in cross multiplication, let us write x1 divided by. So here we will write the value for the cross multiplied value, that is the coefficients of x2, x3, x2, x3. So this one we have to cross multiply, that is 6 into 0, that is 0, minus minus 1 into minus 1, that is plus 1, equal to, now put equal to, then x2 divided by, so x2 divided by the coefficients of x1 and x3, that is minus 2 into 0, that is 0, and also here we have to put a negative, that is first one positive, then next one negative. So minus x2 divided by minus 2 into 0, that is minus 0, then minus 1 into 1, that is minus 1, 0 minus 1, equal to, next plus x3 divided by, so x3 divided by minus 2 into minus 1, that is 2 minus 6, that is 2 minus 6 is minus 4, and here the denominator values are the values of x1, that is here the eigenvector x2 is equal to, x1 is 1, x2 is minus of minus plus 1, x3 is minus 4. So here we got the eigenvectors directly, that is by cross multiplication we can find the values of x1, x2 and x3 very easily. So while considering x1 we have to consider x2 and x3 coefficients. Then this is plus, next negative, then plus, like that. So x2 is equal to 1, 1, minus 4. Now let us find the eigenvector corresponding to lambda equal to 4. So when lambda equal to 4, this one will be 1 minus 4, that is minus 3, 6, 1, 1, 2 minus 4 is minus 2, 0, 0, 0, 3 minus 4, minus 1 into x1, x2, x3 equal to 0. Now let us find the rank of this matrix. So for that, let us interchange these two rows. That is R1 interchanged with R2. Then 1 minus 2 0 minus 3 6 1 0 0 minus 1 into x1 x2 x3 equal to 0. Now here we can make this element 0, that is R2 implies R2 plus 3 times R1. 1 minus 2 0, 0, then here 6 plus 6, 6 plus minus 6, that is 0, then 1, then 0 0 minus 1 into x1 x2 x3 equal to 0. Now let us make this element 0, that is R3 implies R3 plus R2. So 1 minus 2 0, 0 0 1, 0 0 0. So into x1 x2 x3 equal to 0. Now here also we can go for the cross multiplication. That is, here we can write x1 minus 2 x2 plus 0 x3 equal to 0 and 0 x1 plus 0 x2 plus x3 equal to 0. Then what is x1? So x1 divided by minus 2, then equal to negative x2 divided by, so x2 divided by 1, then equal to x3 divided by 0. And also here we can multiply with negative, so here we will get plus 2 and here we will get plus 1 because this is also 0. So the eigenvectors are 2, 1, 0. So after multiplying with the negative 1, x3 equal to 2, 1, 0. So here after checking that x1, x2 and x3 all are linearly independent eigenvectors, so we can diagonalize the matrix A. Now let us go for the diagonalization. So here P is the column matrix of the eigenvectors. Now let us go for the diagonalization, that is D is equal to P inverse into A into P. So we have to find P inverse. So what is P inverse? Adjoint of P divided by determinant of P. So what is determinant of P? Determinant of P is equal to minus 3 into 0 plus 4 minus 1 into 0, then plus 2 into minus 4, that is equal to minus 12 minus 8, that is minus 20. So determinant of P is equal to minus 20. Now we have to find adjoint of P, that is for that we have to find the cofactor matrix, that is we have to find cofactor elements. A11 equal to minus 1 raised to 2 or plus 1 into M11, that is M11 is the minor of the first element, that is 0 plus 4, that is plus 4, then A12 equal to minus 1 into M12, so M12 is 0, then A13 equal to 1 into minus 4, then A21, so A21 is minus 1 into 0 minus 8, that is plus 8, minus 8 here. Then a22 equal to 1 into, so a22 is 0. a23 equal to minus 1 into a23 is 12, that is minus 12. a31 1 into a31 is 1 minus 2, that is minus 1. a32 equal to minus 1 into a32 is minus 3 minus 2, that is minus 5, equal to 5. Then a33 equal to 1 into a33 is minus 3 minus 1, that is minus 4, minus 4. So the cofactor matrix equal to 4, or we can directly write the adjoint, because adjoint is the transpose of cofactor matrix. So adjoint of P equal to 4, 0, minus 4. So write these column wise. Minus 8, 0, minus 12, then minus 1, 5, minus 4. So this is adjoint of P. Now P inverse. So what is P inverse? P inverse is adjoint of P divided by determinant of P. That is 1 by minus 20 into this one. So let us multiply with this negative here. So we will get 1 by 20 into minus 4, 8, 1, 0, 0, minus 5, 4, 12 and 4. So this is P inverse. Now we have to find this one. That is P inverse into A into P. So D is equal to P inverse is 1 by 20 into minus 4, 8, 1, 0, 0, 5, 4, 12, 4 into A is 161, 120, 003 into P. P is this one, minus 3, 1, 2, 1, 1, 1, 0, minus 4, 0. Now we have to multiply this one. That is 1 by 20 into minus 4 into 1. That is minus 4 plus 8. That is 4. Minus 4 into 6. That is minus 24. Then plus 16. Minus 8. Then minus 4 into 1. Minus 4. 0. Plus 3. That is minus 1. Then 0, 0, 0, 0, 0, 0, 0, 0, 0, then 0, 0, 15. So this is 15. Then 4, 12. Then 24, that is 48. Then 0, 12, that is 16. Into minus 3, 1, 2, 1, 0, minus 4, 0. That is equal to 1 by 20 into minus 3, minus 12, minus 8. That is minus 20. Then minus 8. That is minus 4 plus 4. 0. Then 8, 0. 0, 0, 0. 0, 0, 54, 60. Then 0, 0. 16 into minus 3. That is minus 48 plus 48, 0. 16, 48, 64, that is 0. 32 plus 48, then 0. 80, and that is equal to minus 1, 0, 0 divided by 20. Then 0, 3, 0, 0, 0, 4. Here we got the diagonalization of the matrix A.
That is, here the diagonal elements are the eigenvalues of A.
So in this way we are doing the diagonalization of a matrix of order 3 by 3. So in the next class let us discuss more problems. So thank you for watching the class. Please like and subscribe my channel.